Hello, welcome to Chapter 8, Lesson 1. We're going to be learning about functions tables. So today we're going to find the outputs. And we're also going to find input. So the real-world link. A ruby-throated hummingbird beats its wings about 52 beats per second. Make a table showing how many times this bird beats its wing in 2 seconds. So the first thing we have to do is find the expression. And this is from chapter 6. So they find the expression, and they know this expression is going to be s seconds times 52. So this is going to be our input, number of seconds, and then here will be our output. So this is what we put in, and then what we get out is the wing beats. So s times 52 seconds, 2 is going to equal s. So we have 2 times 52, so we're going to have 104 wing beats per second. Now if it says if it beats its wing in 6 seconds, so now we're going to have 6 times 52. And that's going to be 312. Now we have to do a table for 20 seconds. So I'm going to put number of seconds 20. So s equals 20 now. 20 times 52 is going to be 1040. It says a giant hummingbird beats its wings about 10 times per second. Make a table to show how many times the giant hummingbird beats its wing in 3 seconds. So we have 3 seconds as our input. We have s times 10, so 3 times 10. So we have 30 wing beats. So a function is a relation that assigns exactly one output value to one input value. The input of wing beats, the number of wing beats, the output, depends on the number of seconds, input. The function rule describes the relationship between each input and output. You can organize the input-output values in the function rule in a function table. In a function, the input value is also known as the independent variable, since it can be any number you choose. The value of output depends upon the input value, so the output is going to be the dependent variable. So this is the output is 7 more than the input. Complete a function table for this relation. So the output is 7 more than the input. So if it's 7 more, then our function rule is going to be x plus 7. So if input is 10, 10 is going to equal x. So we have 10 plus 7. It's going to be 17. If the input is 12, it's 12 plus 7 is 19. If our input is 14, that's 14 plus 7, and that's going to be 21. The output is 5 times the input. Complete the function table. So our function rule is going to be 5x because it's 5 times the input. So we have 5 times 8 is 40. 5 times 10 is 50. And 5 times 12 is 60. 8, 10, 12, 40, 50, and 60. So go ahead and try A and B. So for A, we have our input values 4 minus 4 is 0, 7 minus 4 is 3, 10 minus 4 is 6. And for B, we have 3 times 0 is 0, 3 times 2 is 6, 3 times 5 is 15. So now we're going to do the backward strategy. This is when we have the output, but we need to find the input. This is find the input for the function table. Use the backward strategy to determine the input. If the output is found by multiplying by 3, then the input is found by dividing by 3. So I have to work backwards. So is 3 times x, so 3 times 2, or in this case, I know 3 times 2 is 6, so my input is going to be 2. Same here, 3 times 5 is 15, so my input is 5. 3 times 7 is 21, so my input is 7. Or I can just divide. 6 divided by 3 equals 2, 15 divided by 3 is 5, 21 divided by 3 is 7. This is very similar to the inverse operations. So go ahead and try C and D. Now I'm going to go ahead and do C with you. So this means 2x minus 1, and that has to equal 1. If I can't do this in my head, then I'm going to do this on the side. I know 2x minus 1 equals 1. I'm going to use inverse operations. I need to get rid of everything except for my x. So I'm going to add 1 plus 1 plus 1. And these are going to cancel. So now I'm left with 2x equals 2. So now I have 2 times x. I'm going to divide by 2, divide by 2. X equals 1. So it's going to be 2 times 1 minus 1. So my input is 1. So now it equals 3. So 2x minus 1 equals 3. So plus 1 plus 1. We have 2x equals 4 because 3 plus 1 is 4. So I know 2 times 2 equals 4x equals 2. So 2 times 2 minus 1. And since this is 5, I'm pretty sure I'm just going to add 1 more to my x. I'm pretty sure it's going to be 3. 2x minus 1 equals 5. Plus 1 plus 1. That cancels. I get 2x equals 6. Divide by 2 on each side. X equals 3. So 2 times 3 minus 1. So I'm going to do the same strategy for D. So by using the same strategy by inverse operations, I should get 5, 6, and 9. Okay, example 4, it says the Gomez family is traveling at a rate of 70 miles per hour. The function rules represents the situation as 70x, where x is the number of hours. Make a table to find how many hours they have driven 140, 280, and 350 miles, then graph the function. So they have a function table of 70x. We have our output values of 140, 280, and 350. So 70 times 2 is 140, 70 times 4 is 280, 70 times 5 is 350. So we have 2, 4, and 5. And our graph should look something like that. And then if you look, you see that the input is x and the output is y. So to graph this, I go 2 on my x coordinate and 140 on my y coordinate. 2 my x and then 140 on my y. 4 on my x, 280 on my y, and then 5 on my x, 350 on my y. So we can also use this to graph. So that becomes, so my coordinates become 2, 140, so my ordered pairs, 4, 280, and 5, 350. So go ahead and try E. It says Brianna bikes 12 miles per hour. The function rule that represents the situation is 12x, where x equals the number of hours. Make a table to find out how many hours she has biked when she's gone 12, 36, and 48 miles. So we know she's gone 12 miles, 36, and she's gone 48 miles. So no, 12 times 1 is 12. 12 times 3 is 36. 12 times 4 is 48. So now I have my ordered pairs of 1, 12, 3 and 36, and 4 and 48. So now I just graph it on the left side. 1, 12, 3, 36, 4, 48. And that's the end of the video, so thank you for watching.